Hello, everybody. It's such a privilege to be back working with this community again, albeit I am dialed in at the moment from Tampa, Florida. It's very early in the morning here, but this is a great way to start my day. Before I get started, I did want to set maybe just a little bit of context around what it is that we're going to be talking about today. If you think about it, single source measurement, panels, diaries, surveys, have really been the backbone of the market research industry for really the 20th century. We measure activity in a small subset of the population, and then we project that out against a universe estimate. These data sources are really good and very valuable because they give us the advantage of being able to directly tie media exposure and consumer behaviors to deep and rich demographic information. But here's the problem. The number of paths that consumers can take to consume media and to purchase products has expanded exponentially in the last 20 years. All of the various permutations and combinations of consumption make traditional single-sourced survey-based measurement much, much more difficult. Why is that? Well, it's because if we expect people to record everything that they do for us, it's a really big ask. It's hard to remember everything that you did, and it's very time-consuming and puts a burden on the panelists. So if we're going to rely on traditional research methodology, as media continues to fragment, we need to ask more questions to understand the complexity of behavior, the complexity of brands. And when we ask more questions, basically that puts a higher burden on the respondent themselves. And that leads to fewer respondents, and it actually starts to undermine the quality of the responses that they give. So it gets harder and harder for individual data sets to give us pervasive measurement. Think of it like this. Given all of the choices that people can make today, how likely are we to observe a specific combination of exposures and actions directly in a single sample? We end up with a limitation in coverage. Yet we all have the same measurement need. Advertisers, planners, publishers, broadcasters, all still want to know what people are consuming, what products they buy, and what activities and services they use. But here's the good news. We're living in an information age. There are a multitude of data sources that are available, panels, surveys, and the emergence of big data all help us to capture a piece of the puzzle. As a market researcher, my challenge lies in finding a logical and a robust way to bring that information together and build a complete view of the individual. So let's open up some slides and take a look at this in a little bit more detail for you. So what is a fusion? At its core, fusion is a statistical process of merging two or more different data sets at the respondent level in order to create something that really ends up being greater than the sum of its parts. It gives us a single database, which enables us to cross-analyze an individual's purchase intentions and habits with their media consumption of print, of digital, and of TV media. At the same time, and very importantly, the fusion maintains the integrity of the currently available currency data for both TV and print, without putting an increased burden on the respondent to answer more and more questions. Fusion has a number of different uses across a number of different industries, and it's been used in market research really since the late 80s. It's the advance of computer technology that's really allowed statisticians to build more sophisticated and robust fusion algorithms, and that's what's really brought fusion into prime time. Before we get into the technical details, I thought it might be useful for us to step through a really simple example to help you to sort of visualize what the fusion is trying to achieve. Some of you may have seen these slides before, but I think it's a really helpful refresher for us in today's conversation. So let's imagine that I want to know how many people watched a particular game that was broadcast on TV, and also how many people bought a particular brand of soft drink. Now, the TAMS panel that comes from the BRC can certainly tell us who saw the game. The Nielsen consumer survey that Terry talked about can also tell us who bought the soft drink, but neither study can tell us who did both. So how can fusion solve for this? Well, let's break it down. On the top row of this chart, you can see a representation of the information that we get from TAMS. And it shows us on the left-hand side that 3 people meter respondents watched the game. And you can also see that 4 people did not watch the game. On the bottom row, you see a representation of our consumer purchase panel. 4 respondents bought the soft drinks and 3 did not. So how do I understand the intersection of these 2 activities? Well, let's assume that the color coding on this page represents the particular characteristics of each respondent across the 2 data sets: their age, their gender, where they live, and a range of other definitional characteristics. Now, a keen eye will start to see some relationships or common characteristics that exist across the TAMS and the CPS respondents. Let's focus on the demographic characteristics represented by the green and the yellow profiles. So with the fusion, if those characteristics, if I use those green and yellow characteristics as a matching criteria, what you can see is that we have 2 matched profiles that both watched the game, which you can see represented on the left-hand side, and bought the soft drinks on the right-hand side. So by matching those respondents with similar characteristics across the 2 data sets, we start to get an appreciation of how many people, and more importantly, who undertook both activities. Now, if that were all there was to it, I'd be done with my presentation today and would be able to move on. But it's going to come to as no surprise to any of you that Fusion 2020 is a little bit more complex. So let's spend a bit more time getting into the science behind the fusion so that you really have a better understanding, not only of the power of this product, but also the credibility and the robust nature of the outputs and the analysis that it produces. So some key takeaways on this slide. The first thing that I want you to all take away from today is that fusions are not built based on finding the same individual respondent or the same person across 2 data sets. Indeed, as we just saw in our example, the core underpinning of the fusion is the assumption that human behavior is largely predictable, that people with similar characteristics behave in very similar ways. Now, there's a lot of statistical research behind that assumption. And in fact, if you think about it, it is the foundation of any sample-based measurement system. The key to the fusion is really about understanding which characteristics are the best for predicting those behaviors. So the fusion process starts with 2 data sources. One we define as a donor who is going to transfer all of their information to the recipient. After that initial integration is done, we can then add more and more data sets to create a much larger and richer set of information. Fusion relies on what we call very carefully selected hooks, also referred to as linking variables or matching variables. And these are the things, the attributes that best predict the individual's behavior. On the diagram, these hooks are represented by the intersection of the red and the gray circles. Now, these variables are the basis for deciding which respondents in the donor survey are the closest in profile and behavior to those in the recipient survey. There's a couple of things to remember as we think about these linking variables or matching variables themselves. First, obviously, they have to be good predictors of behavior across both data sets, whether that be, in our case today, purchase behavior or TV viewership or internet usage or print readership. They also need to be very well matched across the 2 surveys and not statistically redundant, and we'll talk a little bit more about that. The selection of the linking variables begins with a very basic analysis of sample sizes, of profiles on the donor and the recipient databases. And that helps us to identify all of the potential common variables that we may have access to. When we assess whether those hooks, then what we do is to assess whether those hooks satisfy 2 criteria. Are they complete? Do they tell us everything that we need to know? And are they congruent? Do they line up? Are they something that can actually be associated with one another? Once we validate that these variables are statistically significant, then the hooks are used to match those respondents. And that allows data from the donor survey or the donor database to be transferred onto the recipient. Once we've done that, we've now got a complete view of a respondent, albeit a virtual one. Now, there are a few different flavors of fusion to talk about. There's a one-to-one fusion that you may hear reference to, where there is only ever a single match between an individual donor and an individual recipient. There's also a one-to-many fusion, when individuals may be matched multiple times on either the donor or the recipient side based on our requirements. And I'm going to come back to that in a little bit later on this morning to really explain why we might need to do this and what that means for the data and for the outputs. I may have made the cardinal sin. There we go. Okay. So, as you heard Josephine say in our introduction, Fusion 2020 is a little bit more complex than even the example that we talked about previously. It doesn't use two data sources. Rather, it's the first four-way fusion that's used for media research in South Africa. This means we have four data sets that we're trying to integrate. Now, when you set up a fusion, the first thing that you need to do is decide which data sets will be the donors and which data set will be the recipient, because you only ever have one recipient database. In the case of Fusion 2020, we determined that PAMS would be the recipient data, or the hub, because of its very robust base. It has a very large sample with over 15,000 respondents, but more importantly, the PAMS survey is very, very comprehensive. And that means that it already has most of the variables that we will need, variables that are in fact common across all of the other data sources. And that's really important, as you can appreciate, if we want to try and start matching based on characteristics. So because we've got all of those variables already contained within the PAMS survey, this increases the number of hooks that we can use, and that therefore improves the output quality of the fusion itself. So with PAMS established as the recipient, or the hub, the first thing that we did was to take the TAMS data that Gary has talked about already today, which is the red circle on this slide. Let's go, was that me? There we go, sorry. The red circle on this slide. We fused TAMS to PAMS using hooks like the type of pay TV service available or subscription available in the household. The gender, the age group of the household recipients, household income, and a number of other things. Now this is, as I've mentioned earlier, one of those many-to-one fusions. Individual PAMS recipients are matched to multiple TAMS donors. This process actually results in an increase in the number of fused respondents, which I hope you can see now, which takes us from the 15,000 respondents in PAMS up to a total of 24,000 respondents, 24,500 respondents in the fused database. Again, I'm going to come back in just a minute to why this happens and why that's an important thing to understand. So the next thing that we do is to take the CPS panelists, the yellow circle here, and then fuse that onto the combined database. This is now a one-to-one fusion, and we use things like newspaper readership, internet usage, even things like the proximity of the household to a post office or a police station, because we know that those kinds of things can influence the sorts of behaviors that we want to measure. So those are some of the flexibility that you see in the hooks that we use. And then lastly, the green circle, the Nielsen DCS survey, which Terry talked about, is fused using things like overall media consumption, internet usage on cell phones or computers or tablets, household size, presence of children, all of those other things that provide good indicators of digital consumption. So after the fusion, we now have a single respondent level data set that provides a very comprehensive view of media consumption patterns that can then be segmented across many different dimensions and audience characteristics in terms of the consumers themselves and what the consumers do in their day-to-day lives. So let's talk a little bit, let's come back to that notion of why does the respondent count increase? And this is a really important thing to understand, because as I mentioned, while the CPS and the DCS fusions were one-to-one, where we match individual donors to individual recipients, in the case of the TAMS fusion, we use this many-to-one fusion. And we do this for a very important reason. And that reason is that both the TAMS and the PAMS data sets are currency databases. And because they're currency databases, because we trade large volumes of transactions based on the data in those surveys, we need to make sure that we preserve that currency status within the final fused database output. So how do we go about doing that? Well, if you think of it from a TAMS perspective, we need to make sure that every piece of TAMS information is included in the fusion. That means that every TAMS donor, every single recipient, and all of their information needs to be accounted for in the FUSE database. As we got deeper into that fusion process and we started matching donors to recipients from TAMS to PAMS, what we found was that there weren't always enough best matches of the PAMS recipients or to the PAMS recipients, often because that best match had already been assigned to a previous TAMS donor. Okay, so you kind of run out of people for the TAMS panelists to match against. So as you can see in the diagram on the right-hand side here, the fusion methodology allows us to do what we call fragmentation. We end up virtually splitting some of the PAMS respondents into multiple virtual panelists. And this is how we can ensure that there is a best match recipient for every TAMS donor. And in that way, the TV currency is preserved. But if we split those PAMS recipients, what does that do? How does that impact the PAMS currency? Well, in short, it doesn't. Because effectively what we end up doing is apportioning the weights of the individual PAMS recipient across their respective fragments. So again, look at the diagram, and what you can see if you focus on the red text is that Clara, who is the PAMS recipient, has an initial weight of 9,000 in the PAMS sample. And again, this is just an example for you to conceptualize what's happening. When we fragment Clara, or we break her out into some individual virtual components, we want to do that to make sure that we have best matches for 3 of the TAMS donors in particular. There you can see Larissa and Paulette and Charisse. I was very creative with the names today. When we do that, our fusion engine effectively divides Clara's initial weight across each of those virtual panelists. So you can see that that 9,000 breaks down into individual weights of 3,000, 4,000, and 2,000. So by doing this, even though the number of respondents has changed effectively in the PAMS sample by cloning these people, even though the number of respondents has changed, the sum of the weights of all of the respondents remains identical. And that's how we make sure that the PAMS currency is also maintained in the FUSE database. So I hope you've got now a little bit of a deeper understanding of the theory of fusion and how we put all of this together. But let's cut to the chase. What you really want to know, I hope, is what you can actually do with all of this interesting data. So here we're looking at one of the types of analysis, and only one of the types of analysis that we can produce. And on this chart, we can see the incremental reach for purchases of a set of chocolate brands across a number of different types of media. Look at Lunch Bar on the left-hand side of this chart. You can see that 46% of purchases of Lunch Bar can be found and reached very easily through readership, right? So readers, 46% of Lunch Bar purchases are reading newspapers, magazines, and all those sorts of things, both online and on paper. But we also know that if Lunch Bar wants to build their reach and find more and more purchases, they can find an additional 37% of their audience using television. And then above that, an additional 6% can be found on social media platforms. Now, what's really interesting about the fusion, particularly as you look across all of these individual brands, is that you can actually start to differentiate incremental reach by brand themselves. Look over on the right. Now, Lindt chocolate, it's a little bit more of a niche brand. But what you can see is a very different distribution in the column on the right-hand side. See how the social media incremental reach for Lindt is over 2 times higher than some of the larger, more mainstream chocolate brands. Here's an extension of the Lunch Bar analysis. We're now looking at reach by TV channel, broken out by time of day. SABC1 looks to be the best option to maximize reach for Lunch Bar purchases. But look at how DSTV, the yellow line towards the top of the screen, does a really good job of finding those purchases in the afternoon hours between 3 and 6 p.m. It's also not surprising to see that the reach numbers are lower for those channels that skew towards younger audiences. And the reason that the data would support that is that obviously in our purchasing models and in our CPS panel, children are not usually designated as the dominant purchasers within each household. The purchases are usually made by the adults. So the two examples that we just looked at were pretty obvious applications, I guess, of the fusion and looking across media at all of the information that we can get when we put this data together. But I also, excuse me, I also wanted to highlight just how flexible this solution really is. So what we're looking at here is a 360-degree view of an auto purchaser. From the PAMS database, we know that 3.5 million people purchased their current vehicles as new. So what else can the Fusion tell us about these people, about these consumers? Well, all of the percentages that you see highlighted in yellow show how many new auto purchasers consume the things that you see in the gray column on the left-hand side. So look at the broadcasters. Look at how those consumers or how those auto purchasers are consuming TV media. 52.6% of new car buyers watch SABC1, the national broadcaster. Now, that in itself is interesting, but what's even more interesting is when you start to compare that to the national average. The national average coming out of the TAMS rating service tells us that actually, compared to that 52.6%, new auto buyers are under-indexing on SABC1. The national average is actually 69%. Equally, on the other side, you can see that 55% of those auto purchasers watch DSTV. That compares against the national index of 42.2%. So we are over-indexing on DSTV. If you look at this through the lens of consumer purchasing, you find some other interesting things. So for example, here, you can see that 86% of new car buyers live in a household where instant coffee is purchased. If you compare that to the national average of 79%, you start to be able to create some really interesting relationships between consumers of different products. On the digital consumption side, you can see that 22% of new car buyers do online shopping during office hours, during the hours of 9 to 3 p.m. Now, again, this is really interesting because that 22.5% compares against a national average of people who are doing online shopping at that point in time by 12%. So you know you can go and find these buyers, these consumers on the digital platforms. What about readership? Well, the average number of paper print magazines read by new auto purchasers, you can see, is 2.04. Again, compare that to the national average of 1.54, and you start to get a really good sense, if I'm an advertiser or a planner, of where you will find the consumers that you are looking for. There's a lot more analysis that you can go into and many, many more things that Peter will talk about in a minute. But hopefully now you've got a bit of a sense of the power of the Fuse database and what you can actually do with it. So I thought I'd just take a minute to talk about sort of where we're going from here. Fusion obviously has been around for a while, and you heard me say that earlier. Nielsen's commercial use of the product really dates back to 1995, when we deployed what we referred to as the Panorama product in New Zealand. This was a fusion of TV ratings onto the local print data. Since then, we've grown our capabilities, as has the entire industry. Nielsen now has a dedicated global team who run commercial data fusions in North America, in Europe, in Asia Pacific, all over the world. And as you know, we've been successfully using Fusion as part of the PAMS and CPS product that we launched in South Africa 2 years ago. As the technique continues to expand its footprint, and particularly as the media industry in general focuses more intently on trying to understand cross-media exposure and how that leads to outcomes, purchase decisions, brand lift, things like that, what's happening is that the fusions continue to evolve. The techniques continue to evolve. And as with many things measurement related right now, we see the future of fusion centered around more sophisticated big data solutions, moving to more real-time information that incorporates a number of other what we call signals that we can draw from our data sets beyond just a static survey response. Longitudinal data is becoming increasingly important to identify trends and really start to look at the longer-term impact of things that help fill in some of the gaps that we often encounter when we're measuring media in an increasingly fragmented environment. Some of the techniques that we're incorporating through Nielsen's Fusion products and our data integration solutions include very scientific things like max entropy, Bayesian modeling, regression analysis, and a range of other things. And I really hope that we'll be able to talk more about those as Fusion 2020 continues to evolve in your market. Oh, let's go back. Can we go back just one more slide? Lost it. So look, before I wrap up and hand over to Peter, I just wanted to quickly summarize why we think Fusion is such an important part of the future to the media landscape. First of all, it's very cost effective and convenient. You don't need to run any additional primary research. It fits into existing analysis systems. You don't really need to buy any more software or create any more computing power. And most importantly, it continues to allow you to harness existing currency data so that that currency gets preserved and maintained, and all of the metrics that you're using to trade upon today are preserved. It's also something that gives you that respondent level flexibility. So even through the analysis that we just looked at, you can imagine that underneath all of that, we can get down to a respondent level understanding. And that gives us a very deep understanding of reach and frequency, and more importantly, where you can go to find the consumers and the users that you're looking for. It's a statistically precise solution. So, if you really get into the detail of what we're talking about, there is a lot of robust quality checks and reviews and validations that we do before any of this data gets released to you in the marketplace. And then finally, it obviously improves planning efficiency because you get to have everything in a single database. You don't have to spend time merging and integrating data across different sets. On behalf of Nielsen Media and my data science team, we're absolutely thrilled to be partnering with the PRC and the BRC on this initiative. And we're really looking forward to continuing to enhance and evolve media measurement in South Africa.